Hey guys, today we're going to look at 3.3, which is going to talk about the unit circle. So to help us kind of build the unit circle and figure out how all the pieces connect, first thing we're going to do is start with our base right here. I know this kind of looks like a lot, but we're going to kind of build it piece by piece. So what I'm going to start with is my axes. My x axis going across right here, and my y axis going up and down right here. I need to label these. And we are talking about a circle. So we're going to talk about how our degrees go around our circle to start, because we've done that since the beginning of the semester. So right here, I'm starting at 0 degrees. Then as I go up my unit circle, I go up to 90 degrees at the top of the y-axis. Then I keep going around. Back on the x-axis over here, I'm at 180 degrees. Then I go down to 270 degrees. And I come back around all the way around the circle is 360 degrees. And you can see I already have the degree signs there for you to be able to kind of fill in as we're going. But what's new in this unit is that now we've learned that there's more than just one way to measure our angles. We have degrees, but we can also measure our angles in radians. And we talked about that in 3.1, which we have right here. We had a table where I had you convert a lot of different degrees into radians. And if you'll notice, some of the ones we just talked about, 90, 180, 270, and 360 are on this table. So I'm going to go ahead and take those and put them on my circle as well. So 90 degrees is pi over 2, 180 is pi, 270 is 3 pi over 2, and 360 is 2 pi. So I'm going to put all of those on my circle. Now, one that we do have on our circle here that we didn't actually convert is 0 degrees, but if we're starting at 0 degrees, that's also going to be 0 radians. So 0 up here at 90 degrees is pi over 2. I'm going to do it as pi, make that my fraction bar over 2. 180 was pi. Down here at 270 was 3 pi over 2. And back at 360, all the way around the circle is 2 pi. Now you'll notice we also have some points on the outside of our circle. So let's come to this page right here that talks about the unit circle. A unit circle has its center at the origin, and it has a radius of 1 unit. So when we're looking at it, everywhere it hits on the axes, the x-axis and the y-axis, has a point that matches with it, because remember we're putting it in our xy coordinate plane, that has a radius of 1 unit. So if I'm going over to the right on the x-axis, that would be over 1, but I didn't go up or down, so the y value is 0. So it's got an xy point that connects with it. So 1, 0, 0, 1, negative 1, 0, and 0, negative 1. I'm going to label those on my circle as well. So over here is 1, 0. Up here is 0, 1. Over here is negative 1, 0. And down here is 0, negative 1. And there are my axes for my unit circle. Now, you may have noticed that at the top of our notes right here, I have our special right triangles. Let's talk about how those connect to our unit circle. So I'm going to start with the 30, 60, 90 triangle over here. And I'm going to remember how my sides all connect. Across from the 30-degree angle is our side, let's say L. You use whatever letter you would like. I say L for length. And across from my 60-degree angle would be the side L square root of 3. And across from my 90-degree angle is 2L. Now let's say I were to take a 30, 60, 90 triangle and put it inside my unit circle. My hypotenuse would make a radius of the circle, and so that's what I have right here. I've got a 30, 60, 90 triangle where my hypotenuse is a radius, and remember the unit circle has a radius of 1. 1 unit, let's say 1 inch, for this. It's just one unit, so it could be inches, meters, centimeters, kilometers, miles, whatever. 1 unit. So let's see if we can use that 30, 60, 90 triangle table right there to figure out what our missing sides are. So I'm going to make my table down here. 30 degrees, 60 degrees, 90 degrees, L, L squared of 3, and 2L. And I know the side that is across from the 90-degree angle, so I know this side over here is 1, which means I know that 2L is equal to 1. I'm going to work backwards to figure out what L is. I'm going to divide both sides by 2, and I get that L is 1/2. So that can fill in right here. L is across from the 30-degree angle, so across from my 30-degree angle over here is 1/2. So that's one of my missing sides. Then, across from the 60-degree angle is L squared of 3. So if I know L is 1/2, I can say that L squared of 3 is going to be 1/2 square root of 3. That doesn't look super pretty though. So I'm going to make it look a little bit nicer, make it one fraction instead of a fraction times the square root. And so that means I can rewrite it as the square root of 3 over 2. Just making it one fraction, making it look a little nicer. So the square root of 3 over 2. And that goes across from my 60-degree angle. So that's going to be the bottom side right here. So if we're talking about putting this in our circle, going this way would be our x value, and going this way would be our y value. So that would make an ordered pair, square root of 3 over 2, 1. So let's kind of go over to our unit circle and see how all this would connect. So if I'm looking, the angle that's connecting to the origin right here is the 30-degree angle. So let's see on our unit circle, our 30-degree angle would be this line right here. Right, 30 degrees right there. But we have more quadrants than just quadrant 1. We need to figure out how that connects to quadrant 2 over here, quadrant 3 down here, and quadrant 4 over here. And this is where we can use our reference angles that we talked about back in chapter 2. So remember, we can find reference angles by using our x-axis and either adding or subtracting them. So if I'm going up into quadrant 2, I would do 180 degrees minus my 30 degrees, which would get me to 150 degrees. And to get down into quadrant 3, I would do 180 degrees plus 30 degrees, which is going to get me 210 degrees. Leave the degree sign there. It's already on the paper for me. And then over here in quadrant 4, I would once again relate it to the x-axis. That would be 360 degrees minus 30 degrees. So that would be 330 degrees. But like we talked about in 3.1, degrees are not the only way to measure an angle. So in that table, I can use my 30 degrees, my 150 degrees, my 210 degrees, and my 330 degrees in the conversions to radians that we did back in our 3.1 notes. So 30 degrees is pi over 6. So I can come up here and write this as pi over 6. I'm going to use that as my fraction bar. 150 degrees was 5 pi over 6. I'm going to come over here and write this one as 5 pi over 6. 210 degrees was 7 pi over 6. I'm going to write this one as 7 pi over 6. And 330 was 11 pi over 6. So I'm going to write this one as 11 pi over 6. And so you can see how all the degrees and the radians match. And if you notice, all of those that I just wrote in the pink reddish color, they all have the same denominator. I wonder if that's a coincidence. Okay, from here, now we need to talk about how to label those points. And that's where our special right triangle comes in with that x and y that we just talked about. Those two missing sides that we found, the square root of 3 over 2 and the 1/2, is how I'm going to come over here and label my point. It's going to be the square root of 3 over 2 and 1/2. But remember, we've got all our other quadrants that we need to label it in. When I go to quadrant 2, instead of going to the right on my x-axis, now I'm going to the left on my x-axis. So instead of it being square root of 3 over 2 in the positive direction on the x-axis, now it's going to be negative square root of 3 over 2 in the negative direction on my x-axis. But we're still at a positive y, so the 1/2 stays positive. When I go down to quadrant 3, we're going to the left, so the negative direction on the x-axis, but now we're also going down, so that's the negative direction on the y-axis, so both are going to be negative. Negative square root of 3 over 2 and negative 1. And when I move over to quadrant 4, I'm back in the positive direction from my x-axis, so that square root of 3 over 2 is positive, but now I'm still in the bottom with negative y value, so the negative 1/2 for my y value. Now that was just my 30-degree angle. Let's go up and look at our other special right triangles. Notice we also have a 45, 45, 90 special right triangle we could look at. So if I look at my 45, 45, 90, remember across from the 45-degree angles, we have the same side length, let's call it L. And across from the 90-degree angle, we have L square root 2. So let's look at a 45, 45, 90 triangle and put that into our unit circle. So that's the second triangle I have right here. I've got my hypotenuse, once again, with a radius of 1 inch, but now my angle down here is 45 degrees instead of 30 degrees. And so now it's going to make that 45, 45, 90 special right triangle. So let's see if we can find our missing side lengths. So I've got my L, L, L square root of 2, and the side that I know here is the side across from the 90-degree angle. It's 1, which means L squared root of 2 is equal to 1. So to get L by itself, I'm going to divide both sides by the square root of 2. So L is equal to 1 over the square root of 2. But remember, we can't leave our answer like that. We have to rationalize the denominator. So I'm going to multiply top and bottom by the square root of 2, which gets me the square root of 2 over 2. So that's both of my missing sides here because they're the same length. So going up and down, I'm going to have the square root of 2 over 2. And going across the bottom, I'm going to have the square root of 2 over 2. So going in my x direction and up and down in my y direction means that I have the point root 2 over 2, comma, root 2 over 2. So that's going to be the point that I'm going to fill in on my circle in a second. But let's fill in those angles first. So when I come over here, my 45-degree angle is my next angle up right here. And remember, we've got to match it in all of our quadrants. So it's got to go over in quadrant 2, quadrant 3, and down here in quadrant 4. So we're going to have to use our reference angles to help us out. So I know here it's just 45 degrees, but to get up to quadrant 2, I'm going to do 180 degrees minus 45 degrees, which gets me to 135 degrees. To get down here to quadrant 3, I do 180 degrees plus 45 degrees, which is going to get me to 225 degrees. And to get to quadrant 4, remember we relate it to the x-axis, so I'm going to use that 360 degrees and subtract 45 degrees. So that gets me to 315 degrees. But remember, degrees aren't the only way to measure an angle. We also have radians. So let's look at our table from our 3.1 notes and see what radian conversion matches with those degrees, since we've already done it in our 3.1 notes. So I'm going to come down at this table and see 45 degrees goes with pi over 4, 135 degrees goes with 3 pi over 4, 225 degrees goes with 5 pi over 4, and 315 degrees goes with 7 pi over 4. I'm going to put all those on my circle with their appropriate degrees. So 45 degrees was pi over 4, 135 degrees was 3 pi over 4, 225 degrees was 5 pi over 4, and 315 degrees was 7 pi over 4. And I noticed that all of those have a denominator of 4. An interesting pattern. All the pink ones have the same denominator, all the purple ones have the same denominator, all the pink ones have the same reference angle, all the purple ones have the same reference angle. Crazy how that works out, huh? Now let's look at our point. We already found our missing side lengths. It's the square root of 2 and the square root of 2. So that's what our point is going to be. The square root of 2 over 2 and the square root of 2 over 2. Now when we go to quadrant 2, remember we have negative x values. So negative square root of 2 over 2, but our y value still stays positive square root of 2 over 2. When we go down to quadrant 3, they're both negative. So negative square root of 2 over 2 and negative square root of 2 over 2. And in quadrant 4, our x value is positive, so positive root 2 over 2, but our y value is negative, so negative root 2 over 2. Now, let's look at our last triangle. We did a 30, 60, 90 triangle, but we looked at if the 30-degree angle was connected to the origin. Now let's look at what happens when our 60-degree angle is what's connected to the origin. So we still have that radius of 1 as our hypotenuse. So our hypotenuse is still 1. And we're still going to have the same 30, 60, 90 table. So across from the 30 degrees is still L. Across from the 60 degrees is still L root 3. And across from the 90 degrees is still 2L. So if I know the side across from the 90 degrees right here, that's still 1. I already did the work over here, right? So I can just transfer it over here. It's going to be the same table. What's going to change though is where those missing sides are going to go. So across from the 30, it's still 1/2, but now our 30-degree angle is the angle at the top. So the 1/2 would go down here as our bottom of our triangle, our x value. Across from the 60-degree angle is still our L squared of 3, so our square root of 3 over 2. But now across from our 60-degree angle is going to go up and down over here. So up and down would be our y value. So our point is now 1/2, and then that square root of 3 over 2. It's switched places from our 30-degree angle being at the origin to now our 60-degree angle being at the origin. So let's take all of that and put it on our unit circle. So I'm going to come over here, and that's going to fill in the last pieces that we have here, these last parts of the quadrants. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4 are all going to have parts that we're going to fill in, and we're once again going to use our reference angles. So in quadrant 1, I know that it's the 60 degrees. To get to quadrant 2, remember we have to relate it to the x-axis, so I'm going to do the 180 degrees minus 60 degrees, which gets me to 120 degrees. Okay, going down to quadrant 3, I'm going to do 180 plus 60 degrees. That's going to get me to 240 degrees. And quadrant 4, once again, it has to connect to the x-axis. So 360 degrees minus 60 degrees gets me to 300 degrees. And once again, we need to make sure we have our radian measures that match all of that, because degrees is not the only way you can measure an angle. We need to have those radians on there. So I'm going to come and look at that table from our 3.1 notes, and you'll look and see that the 60, the 120, the 240, and the 300 are the last parts of the table. I didn't just pick those degrees for that table randomly. So 60 degrees matches with pi over 3 radians. 120 degrees matches with 2 pi over 3 radians. 240 degrees matches with 4 pi over 3 radians. And 300 degrees matches with 5 pi over 3 radians. And would you look at that? Those ones also have the same denominator. So all the pink ones have the same denominator, all the purple ones have the same denominator, and all the blue ones have the same denominator. Interesting pattern there. And now let's fill in our points. So we already found that it's going to be 1/2 and then the square root of 3 over 2. So 1/2 and then the square root of 3 over 2. When I go to quadrant 2, remember our x value is negative. So I'm going to have a negative 1/2 and a positive square root of 3 over 2. Down in quadrant 3, they're both negative. So negative 1/2 and negative square root of 3 over 2. And in quadrant 4, our y value is negative. So the 1/2 is positive, but the square root of 3 over 2 is now negative. And we've filled in our unit circle. Now, you may be asking, why does this connect to our trig class? Why is this important for my trig functions? If I'm looking at trigonometry, what's unique about this unit circle is every single one of these x values at these points that I just found, all of those x values are my cosine values. And every single one of those y values are my sine values. So if I know my unit circle, I know my trig function values for all of these angles. And that does just give me cosine and then sine. But remember, we do have a quotient identity for tangent identity that says that tangent of theta is equal to the sine of theta over the cosine of theta. So that means that our tangent of theta here is equal to our y over our x value. So if I know my unit circle, I know my sine, cosine, and tangent for all of these. And then if I know sine, cosine, and tangent, I can use my reciprocal identities to find secant, cosecant, and cotangent. So knowing your unit circle is really, really helpful here and saves you a lot of time from having to do SOHCAHTOA over and over and over and over again. Now, you may notice there's little spots that talk about positives and negatives. That should match with your all Smarties take calculus. In the first quadrant, all of them are positive and none are negative. In the second quadrant, if you look, our y values are positive and our x values are negative, which remember, y is sine, which matches with the s, and x and tangent, then x being cosine and tangent would be negative because our x value is negative. If I go down to quadrant 3, our x and our y values are negative, but then when I make a fraction out of x and y, the negatives would cancel out, which is what makes our tangent positive and connects with our t. And in quadrant 4, our x value is positive, but our y value is negative. And remember, x being positive matches with our cosine. And then y being negative would also make tangent negative when we make a fraction out of x and y, our sine and cosine. So let's talk about how we can use our unit circle to actually find some of these values. So that's what I have on our next page down here. So it says find the exact values of sine of 3 pi over 2, cosine of 3 pi over 2, and tangent of 3 pi over 2. So if I'm looking for sine of 3 pi over 2 and cosine of 3 pi over 2, that's going to be my x and my y. Remember, your x is your cosine and your y is your sine. Something that helps me remember that is think about it alphabetically, x, then y, and then cosine starts with a C, and then sine starts with an S. C comes before S in the alphabet. So that's helpful for me. I'm going to delete this page from our 3.1 notes so I don't have to keep scrolling so far. If I'm looking for 3 pi over 2, 3 pi over 2 on my unit circle is right here, down at the bottom on the y-axis. So I've got my point, it's 0, -1. So I can come down here, and if my point is 0, -1, well, sine being my y value means that sine of 3 pi over 2 is -1. And there's my answer. Cosine is my x value, so cosine of 3 pi over 2 would be 0. Now, remember for tangent, we have to do a little bit more work. Tangent of 3 pi over 2 would be your sine of 3 pi over 2 over your cosine of 3 pi over 2, or your y value over your x value, which means it would be the -1 over the 0. Now, we can't divide by 0, so our tangent here is undefined. And there's our answers. Let's look at another one. Now it says use the unit circle to find the exact values of cosine of 7 pi over 4 and sine of 7 pi over 4. So first thing is you got to figure out where that is on your unit circle. If I'm looking at my unit circle, 7 pi over 4 would be right here, this purple part of quadrant 4. So our point here is root 2 over 2 and negative root 2 over 2. So if I'm looking at that, root 2 over 2 and negative root 2 over 2, remember that your cosine is your x value. So cosine of 7 pi over 4 would be the square root of 2 over 2. Your sine is your y value. So the sine of 7 pi over 4 would be the negative square root of 2 over 2. And we're done. Let's do another one. Example 4 says use the unit circle to find the exact value of the cosine of 2 pi over 3. So same idea. Figure out where 2 pi over 3 is. So on my unit circle, 2 pi over 3 is up here in quadrant 2. Okay, it's the blue part of quadrant 2. So my point is -1/2 and square root of 3 over 2. So I'm going to bring that down here. -1/2 and then the square root of 3 over 2. Remember, your cosine is your x value. So my x value is that -1/2. So the cosine of 2 pi over 3 is -1/2. So if you have angles that are in the unit circle in between that 0 to 2 pi, you just look at the unit circle and find either your x or your y, or set up your ratio, or if you're looking at secant, cosecant, or cotangent, you would use, excuse me, your reciprocal identity. Now let's talk about what to do if your angle isn't actually in your unit circle. So if you look at this one, example 5, our angle here, it says find the tangent of negative 5 pi over 3. Negative 5 pi over 3 is not in our unit circle. So if I'm looking at negative 5 pi over 3, remember, we can find our least positive coterminal angle, which is something that we talked about back in chapter 1, and that we did in degrees. We would just add 360 or subtract 360, depending on if our angle was negative or positive, until we got something that was between 0 and 360. We're going to do the same thing here, but now we're in radians. So instead of 360, we got to think about which radians matches with 360. Luckily, it's on our unit circle. The radians that matches with 360 is 2 pi. So since I have a negative angle, I'm going to take that negative 5 pi over 3, and I'm going to add 2 pi to it and see if that gets me an angle that is on my unit circle, that is between that 0 and 2 pi. Okay, one of them is fraction, one of them is not. So I can go ahead and write that as over 1 to make it a fraction. And then I can multiply the top and the bottom by 3 to get a common denominator. So this stays negative 5 pi over 3. And this one's going to change to 6 pi over 3. So negative 5 pi plus 6 pi gets me pi over 3, which is on my unit circle. Pi over 3 is right here, the blue part of quadrant 1. So tangent is sine over cosine, or y over x. We've got 1/2 and then square root of 3 over 2. So let's figure out what that is. 1/2 and then the square root of 3 over 2. My tangent of negative 5 pi over 3 would be that y over that x. So the y is the square root of 3 over 2. The x is the 1/2. Remember, we can't leave it as a fraction over a fraction though. So what I'm going to do is I'm going to multiply the top and bottom by 2 so that it'll cancel out those denominators. And remember, multiplying by 2 over 2 is just a fancy way of multiplying by 1. So when I do that, I get the square root of 3 over 1, or just the square root of 3. So if you have an angle that's not in your unit circle, just add 2 pi if it's a negative angle, or subtract 2 pi if it's a bigger positive angle, until you get to something that is in the unit circle. And then our last one is actually going the other way around. Now I have a value and I need to figure out what angle goes with it. So it says find the exact value of s in the interval pi to 3 pi over 2 if tangent of s is equal to 1. So I need to figure out what my angle is, what my theta is. Luckily for us though, it does give us an interval that it's going to kind of tell us a very narrow part of the circle to look at. If I'm looking from pi to 3 pi over 2, pi is over here, 3 pi over 2 is down here on my unit circle. So that means I'm only looking at this part of my circle in quadrant 3. Now let's break down that tangent part. If I know the tangent of s is equal to 1, well, remember the tangent is y over x. I know y over x has to equal 1. I don't like having a fraction there, so I'm going to multiply both sides by x, and I get that y equals x. So I know I have to be in quadrant 3, and I know y has to equal x. So if I come and look in quadrant 3 right here, just this part, there's only one place where y and x are the same thing, and that's right here, my purple part, which matches with 225 degrees, or 5 pi over 4. If I'm looking at my interval, they did give it to me in radians, so I do need to give my answer in radians. So my answer is going to be the 5 pi over 4 radians. And that's it. So your unit circle can be really, really helpful for you to kind of figure out what your trig values are, or if you have a trig value, to go backwards and figure out what your angle is. And that's it for this set of notes. Make sure you get started on your assignment that goes with this. Let me know if you have any questions, and y'all have a good day.